Hello students, myself Ravi Prakash Sharma. I am lecturer of your microprocessor subject. Today we will start the topic of your subject, that is the introduction of 8085. So firstly we will discuss the feature of 8085. It is a 8-bit microprocessor. It is fabricated using single chip NMOS device with 40-pin IC. It has 8 multiplex address and data bus. It works on 5-volt DC power supply. Maximum clock frequency is 3.072 MHz. It provides 80 instructions with different addressing modes. 8085 has 16-bit address line and the 8-bit data lines. If we know the address lines of any processor, we can find out its memory capacity. Similarly, as you seen in the PPT, we have the 2 raised to power 16 is equal to 64K bytes of memory capacity of the 8085. We can calculate by using formula M is equal to 2 raised to power N. We can calculate the memory capacity of any processor. It generates 8-bit IO address, so it can access up to 256 IO ports. It provides 5 hardware interrupts, namely trap, RST 7.5, 6.5, 5.5, I and TR. Next feature of deals with its flag register, accumulator, 1 flag register, 6 general purpose register and 2 special purpose registers. It provides serial lines for input or output data communications when 8085 interfaced with the peripheral device. Students, this is the architecture of 8085, which containing 3 units. One is the processing unit, another is the instruction unit, and third one is about the general purpose register. Processing unit contain accumulator, earth logic unit, temporary register, and the flag flip-flops. Instruction and control unit containing instruction register, instruction decoder, and the timing and control unit. And last one is the general purpose register, which containing 6 8-bit general purpose register and 2 special purpose register, and another 2 more blocks are here. One is the interrupt controller, another is the serial input output controller, and next one is the next slide represented about the arithmetic and the logic group description. First is about the accumulator. It is an 8-bit general purpose register which is connected to the arithmetic logic unit. After the operation has to be performed, the result is stored in its 8-bit ALU. Another is the temporary register, which is not directly accessed by the user, but when the processor performed any arithmetic or logic operations, the data is loaded in the temporary register. Next one is the flag. Flag is actually set of flip-flops which are set or reset depending upon the various operations performed by the processors. When we combine flag register along with the accumulator. This is the program status words, and it's become the 16-bit. Next is the status flags representation. We have the sign flag, zero flag, auxiliary carry flag, parity flag, and the carry flag. First we will discuss the sign flag. Sign flag is set when the result of an operation is negative. Zero flag when we add two numbers, then the result of an operation is 0. This flag is set to 1, otherwise 0. Auxiliary carry flag is set when there is carry out from the lower nibble of the bits. When we add 8-bit, then carries out of lower nibble for the operation, then auxiliary carry flag is set to be 1. Next is the carry flag. When there is carry generated by any operation, then this flag is set to 1. Parity flag is set when result contain even number of 1, and all other flip-flops are don't care conditions. Next is the register group, starting from the temporary register. As we earlier discussed, these registers are not accessed to the user. It is only loaded when there is operation being performed by the processor. General purpose register, 6 general purpose register having data storage capacity of the 8-bit. Special purpose registers are 2. One is the stack pointer, another is the program counter. Both the special purpose register having 16-bit data storage capacity. Stack pointer 16-bit register. When stack is used, previous values are pushed on stack. Then after the program is over, these values are popped back, and stack pointers work on the LIFO principle, last in first out. Another is the program counter. It is 60-bit register used to point the location from which the next instruction to be executed. So next, second unit of your processor is the instruction register and decoder and controlling unit. So instruction register, when instruction is fetched, it is executed in the instruction register. The register takes an opcode value of certain instruction and decodes using machine cycle and send to the control signal. This is the control section of the microprocessor. Timing and control unit. It accepts clock input. Timing control unit is also known as the brain of the processor. Interrupt controller. It accepts different interrupts like trap, INT 5.5, 6.5, 7.5 and INTR. Another is the serial input output controller. It is used to accept serial 1-bit data by using SID and SOD signal. It can be performed by using SIM and ream instruction. Interrupt. So in 2 marks question, this question can become define interrupt. Interrupt is a process when external device can get the attention of the processor. Again repeating, interrupt is a process where an external device can get the attention of the processor. The process starts from the input-output device, and this process is asynchronous. Asynchronous means speed of two processor doesn't match. Classification of interrupt, it is the maskable or non-maskable. Maskable interrupts can be delayed or rejected. Non-maskable cannot be delayed or rejected. So interrupt can be further classified into two types, vectored or non-vector. Vectored means those interrupts are hardwired. Non-vector, the address of the service routine needs to be supplied externally by the device. So in other way we can say interrupt is considered to be an emergency signal that may be serviced immediately as soon as possible by the processor. So 8085 has 5 interrupts. INTR input is the only non-vectored. It is maskable using enable interrupt or disable interrupt. RST 5.5, 6.5 and the 7.5 are the automatically vectored interrupt. Trap is the non-maskable interrupt having highest priority. Interrupts in 8085, non-vector interrupts. The 8085 recognize 8 restart instructions from RST node to RST 7. Each of these would send the execution to a predetermined hardwired memory location. Restart instruction and it's equivalent to its call location. So from the table of the interrupt priority, trap has the highest priority which cannot be masked off or it cannot be ignored. So from first topic, few important questions, that is the feature of the 805, block diagram of the 805 can be considered as important question for your examination point of view. Thank you very much.